Hello friends, this video on Biomolecules part 2 is brought to you by examfear.com. No more fear from exam. Let's start our chapter with carbohydrates or called saccharides. Why it is called saccharides? Because this saccharide word came from sugar. And carbohydrates, they taste sweet. We'll give you the real definition of carbohydrates in the next few slides. So carbohydrate is an organic compound comprising only of carbon, hydrogen and oxygen. This is a very broad definition. This doesn't cover the actual carbohydrate definition, but just understand the carbohydrates will have carbon, hydrogen and oxygen. But that is not the correct definition. I'll give you a better definition in the next few slides. They are generally produced by plants. Please note, carbohydrates are generally produced by plants. Animals, they don't produce carbohydrates. If you see, all these are output of a plant. For example, if you see cane sugar is from the plant. Then you have glucose, and then you have this by glucose, and then you have starch, and then this is rice, wheat, maize, apple, banana, potatoes. All these has carbohydrates. In fact, there are many other fruits, vegetables, cereals which has carbohydrates. I have just listed few of them which has good amount of carbohydrates. So you see, carbohydrates are generally produced from plants. Correct? And they generally have this formula CXH2OY. And that's how the name came. See, the saccharide name came from the fact that the carbohydrate tastes sweet. So from sweet, shakkar is a word. In fact, in Hindi there is a word called shakkar that means sweet. In Greek also shakkar means sweet. So from that word shakkar, sacharide came. That is sugar. The word carbohydrate came because most of the carbohydrates that we observed earlier were of the general formula CXH2OY. So if you see here, it has carbon and water. So water is what? Hydrate, and carbon is what? Carbo. So if you combine carbon and water or carbon and hydrates, you get carbohydrates. So carbohydrates were considered, please note this is in bold, were considered as hydrates of carbon. That is not the correct definition. We have got a better definition now. But earlier, carbohydrates were considered hydrates of carbon. Correct? Because they have a general formula of CXH2OY. So X can have any number. For example, C1, H2O1 is one option. Or C2, H2O1 is another option. So generally they have seen earlier that most of the carbohydrates the chemists have obtained generally used to fit in this formula. And they were nothing but hydrates of carbon. So they call it carbohydrate. So hope you understand why this name carbohydrates or saccharides came. Saccharide word came because of the word shakkar, that is sweet, because these carbohydrates are sweet in taste, and carbohydrates came because most of the earlier carbohydrate compounds which were in this group were having carbon and water in this formula CXH2OY. But there was a myth that this is a myth actually that all the carbohydrates has this formula CXH2OY. This was broken. And how this was broken? So they found that this glucose, that is C6H12O6, that fits into the formula. That is pretty okay because you put X is equal to 6 and Y is equal to 2, you get what? Sorry, Y is equal to 6. Yeah, you put X is equal to 6 and Y is equal to 6, you get C6H12O6. This carbon becomes 6, hydrogen becomes 2 into 6, 12, oxygen becomes 1 into 6, that is 6. So this works perfectly fine, and this is how glucose looks. We will talk about the structure of glucose later, just hold on that. But they found that this is another compound called acetic acid, that is CH3COOH, that also fit into the formula. If you put X is equal to 2 here and Y is equal to 2, then you get C2, that is correct, 2 carbon, H4, 3 plus 1, 4 hydrogen, and oxygen will be 2. There are 2 oxygen. That also fits into this formula of carbohydrates, but actually it is not a carbohydrate. Why? Because it doesn't have property similar to other carbohydrates. It doesn't have property similar to glucose. So that was one flaw. Also, they found that there's a compound called rhamnose. This was the compound, rhamnose. This is actually a carbohydrate. But they were not, this is not carbohydrate. So the chemists were not able to fit this in this formula, CxH2OI. If you try this, if you put x is equal to 6 here, y is equal to, it won't fit in. If you put y is equal to 6 here, this becomes H12, but O has to be 6. It doesn't fit into the formula. So they found compound which are carbohydrates, for example, rhamnose, which doesn't fit into the formula of CxH2OY, and they also found compounds like acetic acid which fit into the formula of CxH2Y, but they were not carbohydrate. So it clearly proves that this myth or this old definition of carbohydrates, that is hydrates of carbon, is wrong. So there was a need for a new, better definition of carbohydrate. So what happened? These chemists did a lot of experiments and they found a better definition of carbohydrates. So the new and better definition is they are optically active. Please note, they are optically active polyhydroxy aldehyde or ketone. They are optically active polyhydroxy aldehyde and ketone. Please remember this 4 words. They are optically active, they are polyhydroxy, and they are either aldehyde or ketone. Or compounds which produce such compounds on hydrolysis, right? So even if a compound X is not optically active polyhydroxy aldehyde or ketone, but on hydrolysis, if it produces such kind of compound, that compound is also called carbohydrates. So carbohydrates are compound which are optically active polyhydroxy aldehydes or ketones, or the compounds which produce such units on hydrolysis. Correct. So if you see here, fructose is one example. If you see here, this is a ketone group here, and polyhydroxy means at least 2 hydroxy, right? That means OH group at least 2 or more than 2. So if you see, there are more than 2 OH group. In fact, 3, 4. Correct. Similarly, here if you see this glucose, this is what COH group. This is aldehyde group. This was a ketone group. The aldehyde group here, and more than 2 OH group. If you see ribose here, ribose has again aldehyde group. This is aldehyde groups, and more than 3, there is 4 OH group. If you see erythrose here, 1, 2, 3 OH group, and there is a aldehyde group. If you see glyceraldehyde, there are 2 OH group and there is a aldehyde group. Correct. So carbohydrates are optically active polyhydroxy aldehydes or ketones. Now you must be wondering why glyceraldehyde is the smallest carbohydrates. Why I don't have carbohydrates with 2 carbons or 1 carbon? The reason why, see, the definition says that you should have 2 or more than 2 hydroxy group. So let's assume there's a 1 carbon and I put 2 hydroxy group. So what happens, we have seen this kind of carbon, if it has 2 OH group, their bulky group, what will happen is water will come out and it will become CO. So that is not possible, that won't be stable. So any minimum 2 carbon for 2 OH group. That is the minimum requirement. Now if I put 2 carbon on the 2 OH group on the 2 carbon, now I need at least 1 aldehyde or ketone group, right? So even if I put a aldehyde group here, I need 1 carbon for this. Correct? So that means the compound which I'll get as carbohydrates will have minimum 3 carbon, and that is glyceraldehyde. It has 3 carbons. Correct? Hope you understand why glyceraldehyde was the minimum or smallest carbohydrate, because the definition says it should have polyhydroxy. The moment I talk about polyhydroxy, I need 2 carbons, because in one carbon if I put 2H group, it will be unstable and the water molecule will come out, and another carbon is required for aldehyde or ketone group. So as I have told, carbohydrates are called saccharides because they are sweet in taste. This is carbohydrate, this is sweet in taste, this is a picture of sugar, and they are also called sugars. And why this saccharide? Because this is saccharide word came from shakkar, a Greek word that means sugar. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.